Hey everybody. Okay, I have a short video for you today for class and then some problems to work on. You can use the calculator or not for the problems. They are just involving slope fields, and then we'll go over those problems tomorrow in class live. Okay, so I have my calculator here set to go, and little did you know your calculator can do slope fields and it can do differential equations. So we've been dealing with differential equations like dy dt equals ky. Our calculator can solve them. We just use a couple of little different symbols on there I'm going to show you. So I'm going to have this document open. If you have your calculator, you can follow along. If not, don't worry. I'm going to hit Control plus page, and I'm going to add a calculator page. I'm also going to hit Control plus page and add a graph page. So back on the calculator page, I'm going to go to the differential equation solver. It's under Menu, and it is under Calculus, and it's all the way down here on differential equation solver. So we've been always dealing with dy dt equals k times y. I'm going to type that in. The only difference here is instead of using dy dt, I actually have to use the symbol y prime. It means the same thing. So I will type in y, and the prime tool is under the pi tool. Y prime equals, and here's the key. I have to do k. You have to do a time symbol times y. You know what? I'll do it p, since we've been doing p the whole time. Let's go p prime. P prime. So it's dp dt equals k times p. It's asking me for my independent variable, which is p. Oops, sorry, not which is t for time. My dependent variable, which is p. And I'll talk about conditions later on. I will hit OK. And if I hit enter, it solved the equation right there. And we knew we could see e to the kt. Now, we don't really need it for that one that much, but all the other ones that we'd done a while ago, let's do it again, Menu, Algebra, no, Calculus, Differential Equation Solver. Let's go with let's say dy dx, that's y prime, equals, we'll make it a fraction, oop. Oh, you can't put the fraction tool in, so I gotta put it in parentheses. Y minus 2 divided by x minus 3. This time I used y and x in the problem, so my independent variable is x, my dependent variable is y. I can hit OK and hit enter, and it's going to solve the equation right there. That tells you what the solved differential equation would be. Now, a couple things. You know in the past how we found C1. We could use it. I'm going to go back to the desolve tool for a second. So I'm going to go grab this right here. Go up to it. Now I'm going to go back the long way. Calculus. Oh, come on. There we go. Differential equation solver. I'm going to put just a standard one in. Y prime equals 2y. Okay, so here's one that doesn't have a missing k or anything like that in it. If you put that in, I'll say this is t. Dependent variable is y. If I knew initial conditions, y of 0, that's a 0, 0 equals 13, and hit OK, and I hit enter, it will actually solve for that missing the constant. It will solve it on in there for you. That only works when the problem is like these second two, because in here we didn't know what k was. When we have more than one missing thing, we can't solve it that way. You can use the solve tool on there. I think it's easier just to do it without the solve tool by putting in the points. But I want to do it once anyway. Let's say we knew that for this problem, the original problem, the initial condition was at time 0, p was 20. I could go menu, algebra, solve. I could then grab this equation. If I said at time 0, p was equal to, what did I say before, 30? If not, I'm saying 30 now. I just put a comma afterwards and tell what I want to solve it for. So I want to solve for C1. Let's see if that'll work. It tells me that 30 is C1. So once I know that, I could use another point and solve it in there. I think really for this part, just the dsolve tool is what we want to use. This is the version you use the most right here. We put in our equation, we tell it the independent variable and the dependent variable, and will give us back the solved differential equation. Okay, now as for slope fields, I'm going to go to the graph page. We can graph any slope field to see what it looks like by, from the graph page itself, go to menu, graph entry, and let's go all the way to differential equation. That's going to allow us to graph the differential equation and see what the slope field looks like. The only key on these problems are, instead of using the letter y, we have to use like y1 or y2. So this says that y1 prime, or dy dx, is equal to, I have to use x. You can see this kind of hints at here. I have to use x and y1. So let's go with negative, it's not a negative, let's go with negative y divided by x. And hit enter. I got nothing. Huh. I don't understand why that didn't work, but I do understand why it didn't work. I'm going to hit tab, not a dollar lane, good try, and go back up to here. When you graph a slope field, your y variable is not called y, it's called y1. I've got to come up here and put the 1 on there. So if you ever graph a slope field and see nothing, that's most likely what happened. I'll hit enter, and there's my slope field. You can see a particular solution, if I started here, would come down and swoop through here, like so. If I go back to the tab button to go back to y1, you can also put in an initial condition, and you can see what that slope would look like. So let's say I wanted to see what the slope field that went through the point 3, 8 looked like. I'd hit enter, and there's the particular solution for that graph right there. I just double clicked on it because I want to show you what happens. The normal one will look like this. X over y, tricked you, y1. I'm going to take out the initial condition. And just so you know, negative x over y, the slope field is that of a circle. We'll solve out to a circle. I'm going to hit tab. If that's what gets me a circle, what gets me an ellipse? Let's go negative 2x over y1. Now you can see you made an ellipse. It changed the shape that way. But any slope field I wanted to see, and then look at a specific solution of, I could just put a number in, 3, 4. Ooh, that was kind of creepy. Doesn't look that good. Let's see if we zoom out if it looks any better. Out. No, not much better. I think I picked a point that was, I picked a point that was right on the slope line. Let's go back to tab. Or did I? Let's go up. Let's go with 2, 4, see if that helps out at all. Now I knew I had a problem graphing on the ellipses. I'm going to go back to my slope field. Let's go with 2 times y1 over x. That's better. So the slope, the ellipses and stuff will not always show up really well. These ones are here. Remember, this slope field is 2y over x. Wherever y1 is 0, our slope is going to be 0. And wherever x is 0, the slope is going to be infinite. You will notice, though, a lot of times on these graphs, they won't draw the infinite lines or the 0 lines exactly. They're there, but you kind of see them on the chart. I'm going to go back to my slope field, and I'm going to graph y1 prime equals x. I'm going to take out the particular solution. Hit OK. And this is the slope field of y1 prime equals x. This says that as x gets bigger in the positive direction, the slope is going to get bigger in the positive direction. But as we change y values, the slope isn't going to change at all because there's no y in the actual slope. So let's take a look. If I look in the x direction, if I start at 0 and slide this way, I can see the slope is getting steeper as we go out. But if I move in the y direction, there's no change in the slope at all. That's because the slope field is only based on x. If I change this from x to y, I'm going to get nothing. Uh-oh, why did I get nothing? That's right, Lucas. I have to put a 1 on there for y1. And now watch, if I change in the x direction, if I move in the x direction, the slope doesn't change. If I move in the y direction, the slope does change. It gets slopier. Let's go back to the chart. Let's go up to this one. And let's say I did y1 plus 3 divided by x plus 4. I'll put that in parentheses. There we go. I'm going to hit enter, and I'm going to see these crazy lines going all over the place. Just wanted to change the window for you here. So here we have a slope field, y1, which is y1 plus 3 over x plus 4. The slope of this graph will be 0 when the top is 0. The top is 0 when y1 is equal to negative 3. Now if you take a look at the graph, negative 1, negative 2, negative 3, you notice that you don't see a straight line there, but think about it. Above it, it's a little positive slope. Below it, it's a little negative slope. That would be where the slope would be exactly 0. And the slope would be undefined when the bottom was 0. It would be infinite when the bottom was 0. Who said undefined? That was wrong, sorry. The slope will be infinite when x is negative 4. So let's go negative 1, negative 2, negative 3, negative 4. And you can see on one side, it's a slope tilting to the right. On the other side, the slope tilting to the left. So there would be a straight line here. You won't always see straight lines on your slope field if you graph them, because it doesn't necessarily plot those things at the exact point you're looking to see. If you need to reduce it down and see more, hold on, you can come into the, oops, stuck. You could turn it up and see more of them. Doesn't really give you a better view of what's going on, but you can use things like this, the calculator, to solve the problems like I'm giving you on your sheet for work tonight. And if I was to bring that up, let's go to calculus. There we go. Your work tonight is going to be solving some slope fields. I'm going to give you pictures, and you're going to tell me which one it is. For this one, for number 1, which is on your sheet, it's going to be one of the 4 solutions here. Well, if I look, when x is 0, the slope is 0. The only one where that's going to be the case is choice A. And if you're not sure on what to do with that, literally pick a point. Let's go to the point 1, 1. At 1, 1, fill that in. The slope is negative 1 over 1. The slope is negative 1. That's how I know it's going to be that one right there. So you're literally just going to test points, or you could graph each of these in the calculator, and you would see what you're going to get. Remember, negative x over y as a slope field is always a circle. Okay, that's enough for now. I'm going to send the sheet with you. You have a number of questions to work on. We'll meet tomorrow in class live and go over those questions together. I shall see you tomorrow.